Lab 2, lines of charge. The purpose, we use charge tape to compare the point charge model from Lab 1 to the line charge model in Lab 2, in which segments of the pieces of the charge tape are given a charge. The experiment in Lab 2 is shown to the right. The charge tape has a net positive charge, and the charge of the tape is seen right there. The magnitude of the electric force is also seen right there. Assumptions, we ignored air resistance, and we assumed that each U-tape had the same amount of energy, and it was evenly distributed along the length of the tape. Models and fundamental physical principles. So superposition, breaking up a charged object into segments and then adding up the electric field from each segment to find the net electric field emitted from it. In second law, force equals mass times acceleration, Coulomb's law, which is force equals charge times electric field, and then electric field from a point charge is shown there. Force of gravity, and then we see Newton's second law again down there using change in momentum and change in time. The diagram to the right is the two pieces of tape. A and B represents the two charged pieces of tapes. Arrows represent the forces exerted on tape B. FG is the force of gravity. FA is the summation of the forces from each segment of A. The small upward arrows are the individual segment forces, while the larger one is the total force exerted. System is the suspended U tape B, and then the surroundings are the held U tape A. The forces are at net equilibrium, so the forces are at equilibrium, so the net force on the U tape is 0. This is the code. So on the left, I defined my variables like the mass and the net charge and the distance between the two pieces of tape. And then in the bottom left, I made the code for the electric field. And then to the right is the code for the individual charges. Then this is where on the top is where I called the functions and put in my values that I had defined earlier, and I broke up the segments into 30 parts. As you can see, n equals 30. Yep. This is how I put each piece of charge in the top tape, and then use that to calculate each charge at each individual piece of tape, and then added it up, as you can see here, to where they combine. So all of the green arrows combine into being the white arrow, and that white arrow is the net electric field from the blue piece of tape on the bottom, and then the yellow arrow is the force due to gravity. And then the net electric force and gravitational force. These are just using the vectors to find what was done, or what you just saw on the picture. And then sources of error, while this is more accurate than the model from Lab 1, it's still not exact because there are a set number of charge segments that the tape is broken into. Here I had 30 segments, but for it to be very exact, we'd have to have an infinitesimally small number of them. Charges of each segment might not be equal and may not be evenly distributed, and inaccurate measurements of tape length, width, and height. What if? So to answer the what if question, a charge of 1.34 e to the negative 8 from lab 1 was found, and a charge of 2.718 e to the negative 8 from lab 2 was found. So the charge from lab 2 was more than double what was found from lab 1. So lab 1 was not very accurate. And why do they differ? They differ because lab 2 takes into account the length of the tape, while lab 1 only considers it a point charge.